All right, you lucky, lucky people who have some time off from school and classes, but of course, you always want to keep your mind active. You always want to stay learning. So here we are. I am Mr. Solt, providing you some online learning like I know you wanted. Like I know you wanted, all right? So go on to that Google Classroom. Depends on, whether you're taking advanced algebra, financial applications, or stats. Um, we're going to be looking at driving data this week on our day off. Now, this section here is going to be due by the end of Friday. Keep in mind, we just finished. We just finished up section 5 in one of the classes. So we have here the practice test and the assessment test for sections 4 and 5. So go on in there and take this practice test, take that assessment. I recommend getting this practice test here to like in the 80% range or above before you go on and take the assessment. You can take this as many times, just turn it in and then I'll grade it, send it back to you, you fix the problems. There's no reason why this practice test should ever be less than 100%, right? You're gonna do your best, you're gonna try, you're gonna turn it in. I'm gonna try to give you some feedback on how to improve any errors, and otherwise I'll say great job on all the things you did right, and then I'll turn that back to you, you turn it back into me with the corrections, and boom, 100%. Sorry about that, got a grandfather clock behind me, that'll ding every 15 minutes. Hope that won't be too bothersome. I'll talk over top of it, okay? So over here we got the real assessment. Again, this is all due by Friday. We're done with these sections, so take the practice test as a practice. Take the real test. The real test is exactly like the practice test, only different numbers, right? Same questions, different numbers. Testing the same exact content, no surprises, like always. All right, we're moving on today to section 6, though. Once you get done with section 5, and hopefully you're getting done with section 5, if you you know what? Let me think about how we want to handle section 5. Because most of you have started this on paper, right? And the paper, of course, for most of you are in the classroom, which you don't have access to right now. And I don't want you to go ahead and put in, start section 5 from the beginning. So I think what we'll do is we'll just put a little pause on section 5. For those of you who aren't done yet, we will, you can turn this into me whenever we get back to school, whenever that is. School's closed indefinitely due to health crisis that's going on with the coronavirus and COVID-19, right? So let's just start this section. This is a new section. You have your Chromebook, right? You got your Chromebook, right? Hopefully, yes. And we can just do this on Google Forms. So you go on to that Google Classroom, you go to the appropriate class, you find section 6, driving data, and then you click on the Google Form. So here we go. Clicking on that Google Form. And here it is. Automobile ownership, driving data, section 6. Let's review those learning targets like always. We're going to have 2 learning targets for this section. This section will take multiple days to complete. I'm not sure how long this video is going to be. I'm shooting for about one class, 49-minute video, and then that'll be all your instruction, and you just kind of work on this as time goes by here, all right? So we'll definitely get you through all the examples today. Excuse me, I'm going to be coughing. I wasn't feeling too well myself this week. Sure hope it wasn't anything too serious. But let's look at those learning targets. Learning target number 1. I can write, interpret, and use the distance formula. Alright? So you need to be able to look at a situation in a real world context and be able to write out what the distance formula is and kind of put those numbers in there appropriately like you need. You also need to be able to interpret the distance formula, what is the distance formula doing, and how to interpret what's happening mathematically behind the scenes, and of course use it. You can write it, you can interpret it, you can use it to find distance or length. And the second learning target is I can use the formula for the relationship between distance, fuel economy, and gas usage. This kind of thing, these are going to be some ratio and proportion conversions, right? We're going to be in the driving data section. We're going to be looking at, if you drive 200 miles and you get 32 miles to the gallon, how much gas have you used? If you get 32 miles to the gallon and you've used 7.5 gallons of gas, how many miles have you driven? If you've driven 500 miles and you get the idea. All right, we're going to get into it. Odometer, some vocabulary first. Let's go over our vocabulary. Odometer. Odometer is that thing on the car that you've all seen that says how fast you're going. Okay, so I'm going to Google search for odometer. Odometer, and I want you just to see some images of odometers. There are images of odometers, right? You've seen these. You know what they are. All right. Electronic odometer. So there are electronic odometers and there are mechanical odometers. Electronic odometers keep track of things as you might expect electronically, using a little mini computer, would be on a wristwatch or something like that. And then mechanical odometer. These are the kinds that you could sometimes play games with and roll the wheels backwards and make it go backwards type of thing. A trip odometer. A trip odometer is a little different than a regular odometer. A trip odometer is telling you like how many miles you've gone on a particular trip. Sometimes your odometer will have. I'm looking for one of these that has a trip odometer. This one here, this right part one here, looks like it has a trip odometer. The trip odometer tells you. You kind of usually press a button, and then you kind of you'll press a button and it'll go to 0, right? So, for instance, for myself. When I fill up my gas tank up at the gas station, I then get in my car after I've put the gas in and I push the trip odometer to 00, and then I drive around for a few days or weeks, and then the next time I get gas again, I fill it right back up to the top, and then I use the trip odometer to determine what my gas mileage was from that point on, and we'll go into that later. So trip odometer. Speedometer. A speedometer is the thing that actually is measuring speed. Odometer is, measuring miles, right? Fuel economy measurement. Fuel economy measurement is basically you're measuring what your fuel economy is. Your fuel economy is how you are economizing on fuel, how well you are using fuel, how much distance are you traveling per gallon of gas. And we usually talk about that in terms of miles per gallon, but you might have heard of this thing called a metric system, in which we talk about this as in terms of kilometers per liter, right? In Europe and Canada, they talk about kilometers instead of miles, because they use the metric system, and they talk about liters instead of gallons. And we'll do some unit conversions at the back of this too. English Standard System, that's what we use in terms of measurement. There's the metric system. That's what basically the rest of the world uses. Even the UK, I think, uses the metric system at this point. Distance formula, I'll show what that is, and currency exchange rates. You may not be aware, but not everyone uses American US dollar bills. And so if you wanted to go to a foreign country and they used, for instance, the mark, you might have to exchange some of your US dollars for marks, and there's going to be a currency exchange rate by which your dollar bill will buy, a certain amount of marks. And it might not be exactly one, right? For instance, let's do a little Google search, right? Let's do a little currency conversion. Currency exchange calculator. Okay, right now, 0.91 US dollars equal to 0.9 euros, which means if you were to go to another country and wanted to exchange your US dollars for euros, you would get 0.9 euros, basically 90% of a euro for $1 American dollar. So for $100, you'd get 90 euros. If that makes sense, right? $100. Oh, you get 89.73 because there must be rounding here. Sorry. Sorry about that. I am still getting over my thing. Alright, there's our standards if you want to take a look. We're rearranging formulas highlight quantities of interest, and there's our mathematical practices of making sense of problems, persevere in solving them, reasoning abstractly and quantitatively, constructing viable arguments, and critiquing the reasoning of others, modeling with mathematics. We're doing a lot of this, modeling with mathematics in this section. Use appropriate tools strategically, attend to precision, look for and make use of structure, and look for and express regularity in repeated reasoning. Okay, like always, you're going to write down your name, and after you get done writing your name, you're going to write down one of these learning targets. Now, when it's on the computer, it's pretty easy. You can cut and paste, but, heck, you might just want to write these out. I don't know. Maybe you could, or you can cut and paste. That's all right. I really just want you to actually take a second to actually look at what the learning targets are. This is like my little check to make sure, students have looked at it at least once. Hopefully they've copied and pasted, and that made them, okay. Anyway, here we are. Warm-up number 1. Maybe you want to pause the video here. Try these warm-ups. Although I'm not really around to look for bonus points right now, so if you're just going to keep pressing play, I guess you're going to find out, alright? So if you want to press pause now, that'll be the time. Okay, you decided to press pause, hopefully. And let me go over these. Alright, so I'm giving you the conversion here. 1 mile is approximately, this is the squiggly sign for approximately, 1.60934 kilometers. How many kilometers then are in 100 miles? Well, if 1 mile equals 1.60934, and then we want to do this, so we have to do, okay, what is the relationship between 1 mile and 100 miles? Well, 1 mile is to 100 miles what 1.60934 is to like this other number we don't know, right? We know that this 1 here is to this, what this 100 will be to that, and if you don't see it already, the answer is going to look like something like, let's see, 160.934. Does that look familiar? You notice how that decimal point just went over, boop, boop, right? It went over 2. Because think about it, 1 mile equals 1.6 of these kilometers. Well, if I'm adding 2 zeros on my miles, like 100 miles, I move my decimal place over 1, 2. And basically it's 100 times the original figure. So I need to 100 times this original figure, and breaking out my calculator. Waiting for calculator. Come on, calculator. Calculator, you're too big. That's better. That's better. I can handle this. You were too big before. Okay, here's my 1.60934 times 100, because why am I times 100 again? Because I went from 1 mile to 100 miles. I times 100 to this number, and I get 160.934. 160.934. See how that happens? Good. All right, let's move to the next one. Warm up. 1 mile equals, I'm giving you the conversion rate, 1.6 kilometers. How many kilometers are there in 237? Oh, well, this one's a little bit harder, right? Because it's asking how many kilometers are there in 237 miles. So we can't just times it by 100, right? But we can just times it by 237, right? Because this is 1 is to 237, whatever 1 point, and again, let's, I normally wouldn't go out this far, many decimal places, except I just talked about the standard of attending to precision, so here I am, forced by learning standards to attend to precision here. So it's going to look something like this is a ratio, a proportion. If I was writing this out, and oh, don't make me write this out. Okay, you're going to make me write it here. I was to write this out. 1, 2, 3, 7. Don't laugh at me because I'm doing this with a mouse. And then I'd have, oh, I'm not going to attend to precision when I'm writing this out with the mouse. I'm sorry. Okay. It's going to look like this. It's a proportion, right? When I'm writing out here is a proportion. 1 mile is to 237 miles. What 1.6 is to this unknown number? Well, what am I going to do? I'm going to cross multiply, right? I'm going to take this and multiply, and then x is going to equal whatever these two numbers multiply to be together to be. All right. So let me. I'm trying to figure out where to put my calculator, where you can see it, and it will be good for everyone. Sorry, technical difficulties, distance learning on the fly in real time here. Okay, what did I want to do? Yes, I wanted to take 237, I want to times it by this number here, right? 237 times 1.60934. There we go. 381.41358. Okay. Oh, no, I don't know about you, but I couldn't remember that long. 381.41. 381.41. Okay. And, do we want to take it out? Do we want to attend to that precision? 358? There we are. Okay, so if 1 mile is 1.6 kilometers approximately, how many kilometers are there in 237 miles? Well, it's going to be 381 kilometers. And, oh yes, I should have done this on both of these, right? When you're working with real-world problems, in real-world situations, you want to always provide the units at which you're measuring things in. So in science, you always want to use units, right? If we're talking about units of measure, like a kilometer, you want to make sure you've labeled your value with that unit of measurement. In math, oftentimes we're talking about abstract numbers, and we can just leave off units of measurements. But here, we really want to make sure we attend to that. Okay, of course you knew I was going to. I was going to make it harder for you. Yes, I'm going to make it harder for you in this question. Sorry, I'm going to cough again. Okay, sorry. So notice that this isn't. We're going to talk about in terms of miles, when the last ones were all in terms of kilometers. So why does this make it harder? Because the proportion changes subtly, right? If 1 mile, and I left off the 1, didn't I? So oops, sorry. If 1 mile equals 1.6 kilometers approximately, how many miles are there in 500 kilometers? Okay, so this is going to look a lot like my old problem, but now let me think about this. I got a 1 over 1 mile is to an X number of miles, because remember, miles is what I want to find out. How many miles is going to be equal to 1 point, don't make me write all that out, 1.6 is to 500. So did you notice that's subtly different? That's subtly different from what we did before, right? Before it was 1 mile over 237 miles equals 1.6 over an unknown number. Now it's 1 mile over the number of miles I don't know. Remember, X just stands for a number I don't know yet. And the technique still applies. I'm going to cross multiply, and the reason why this is just a little bit trickier than before is because now I also have some algebra to do. I have to do 1.6 times x. 1.6 times x equals 500. And then what am I going to do? What am I going to do? Anyone? Anyone? Do you know? I'm going to divide by 1.6, right? Because dividing by 1, I want to get x by itself. To get x by itself, I got to move this 1.6 over to the other side of the equation somehow. I see that 1.6x is really what it means is 1.6 times x equals 500. Well, by dividing by 1.6, I kind of cancel multiplying by 1.6. But if I do it on one side of an equation, I of course got to do it on both sides of the equation to make the equation balance. So x is now going to equal whatever 500 divided by, what did I say? Let me go back and look. 500 divided by 1 point, okay, I got it. Divided by 1.6093. I'm willing to type it, but I'm not willing to write it out with the mouse. All right, 310 miles. All right, so 310 miles, or you could write 310 miles and write it out like that. You can always use these abbreviations. Most people do. And we are done with that. So, why is data important to a driver? I don't want to waste a whole bunch of time reading this out, but data is important to drivers for a lot of reasons. The dashboard is an information center. We get information on how much fuel you got, how fast you're going, what the time is, what the pressure of the oil is in your car, what the temperature of the oil is in the car, right? I've got some, yes, the odometer indicates the distance the car has traveled since it left the factory. I've got some information on mechanical odometers versus electronic. I've got some, you're also concerned with the gasoline used. Here's some conversions from, it's what 1 kilometer equals this many miles and 1 mile equals this many kilometers. And some notes about this. Okay, so you're going to read this on your own. This is some reading for you to do. This will give you some context of what's going on. I don't want to waste any more time on that. Here we go, getting started. Example 1. Example 1, distance formula solving for distance. So here's the situation. Car travels at an average rate of speed of 50 miles per hour for 6 hours. So think about that. 50 miles per hour for 6 hours. How far does the car travel? How far does the car travel? Well, here's how we're going to solve this. The distance the car is going to travel is going to be a function of its speed and the time traveled. So the relationship is shown as the distance formula. Distance is going to equal the rate of speed times the time. right? Distance equals rate times time. D represents distance traveled, R represents the rate at which the car is traveling, and T is the time in hours. So, 50 miles per hour, that's the rate. 6 hours, that's the time. 50 times 6 is 300. The distance is 300. So, here's where you might want to pause and give this a shot. Or if this one actually is an algebraic, is an algebraic expression, and I know some of you struggle with these, maybe you just want to keep watching. Up to you, pause or not pause. Here we go. Algebraic expression, write an algebraic expression for the distance traveled, just tells me to try to plug in this the best, just to create an algebraic expression. So, let's see, the car is traveling at a rate of r miles per hour. It's traveling for a certain number of minutes. Well, you know what I could do? I could do this, right? I could do D equals R times M for minutes, right? That's the only difference that I have from this expression up here. D equals R times time. Right now it's times minutes. Personally, I don't like this one because I almost never am talking about speed per minute. So Mr. Solt would change this to be a little different. If you don't do this, you're not wrong. Not the way the question's worded. I'm going to do minute times 60. Or actually, I think I would like to write this better as 60 M. Why do you think I want to do that? Well, because how many minutes are there in 1 hour, right? And we always talk about speed in terms of miles per hour. So I'm going to write 60 M, 60 times M, essentially. That's the implied thing there. If you want to write it, put a little asterisk in there to have the multiplication symbol. It'd be explicit, that's fine. But what this does is it makes my distance in terms of hours and not minutes. This is not wrong. It's just a preference on how you want to express it. I think that's how I would go. And that way I kind of keep things in this, a paradigm. It's a peculiar window of interpretation, right? I'd like to keep things in terms of hours if I could. I think, given how I feel about what I'm reading here. Next one. This is just notes. Actually, no, this is not notes. This is example 2. I don't know why I call it notes. Oh, because there's nothing to do. So there's nothing to do here. The example is just, we're going to go over it, right? We're going to use the distance formula to solve for time. Here's an example of a problem you might encounter. Jack lives in New York and will be attending college in Atlanta, Georgia. The driving distance between two cities is 883 miles. Jack knows that the speed limit varies on the roads he will travel from 50 miles per hour to 65 miles per hour. He figures that he will average about 60 miles an hour on his trip. At this average rate, for how long will he be driving? So how much time will he be driving given this rate and this distance? Express your answer rounded to the nearest tenth of an hour to the nearest minute. So here's the distance formula. We're going to write that out. We want to get we want to get time by itself, right? Because the question is asking, where did it ask? How long will he be driving? How long? That's they're asking about time. They're asking about time over here. So we're going to try to, what we have? We have D equals R times time, right? Distance equals rate times time. To get time by itself, what we're going to do is we're going to divide by R on both sides. Why? Because that moves the R over to the other side of the equation. This R being multiplied by T is canceled by being divided by R, which means it goes away. And now I get D divided by R equals T. Alright, distance divided by rate equals time. And then I know that the distance is 883. I know that the rate of speed is about 60 miles per hour. Therefore, 883 divided by 60 will give me 14.716. It's non-terminating, it goes 6666 forever. And which means he's going to spend approximately 14.7 hours on the road. Alright, Jack is going to spend about 14.7 hours on the road. So let's see, what are we doing? Oh, we might want to know about minutes though, right? 14.716, we can't really convert that well into, that tells us about how many hours. We know it's about over an hour and a half, right? 14.5 would be an hour and a half. This is 14.7, so we know already it's an hour and a half. But we can actually calculate it to the minute by doing some additional conversions. We can take 14 hours we can take our number, 14.716666 repeating. We can subtract 14 because we already have these 14 hours in hand. We already know what 14 hours is like. But we want to we want to figure out how many minutes is in this right here. So we just take off the 14 that we hours that we know about. We find that, okay, what is 0.71666 repeating number of minutes? Well, we'll times this by 60, and we'll get a number that's a little bit, that is either exactly or very close to 43. And then, so now we can talk about this being 14 hours and 43 minutes with a little bit more precision. If this number gave us a decimal, we could then actually take that decimal piece, that anything less than 1, and then multiply that by 60 because there are 60 seconds in an hour, and then we can find out exactly how many seconds as well. So this is part of that conversion of converting hours into minutes and converting the decimal of minutes into seconds, right? So we're doing that. So Cantonio here, he's going to drive from Atlanta, Georgia to Denver, Colorado. That's a long trip. The distance is 1,401 miles. Looked it up on Google. If Cantonio averaged about 58 miles per hour on his trip, how long is his driving time to the nearest minute? So, all right. So we'll need to do this. So distance is equal to, what is it? Rate times time. Okay? So what's my next step? I know I'm going to have to divide by r on both sides, which means distance divided by r. Distance divided by r equals t, right? Because it asked how long is this driving trip to the nearest minute. It's asking about time. How long? It's asking about time. So that's why I divided by r on both sides of this first equation, because I'm interested in what time is. And now I can start plugging things in. The distance is 1,401 miles. I need to divide by r, which is 58 miles per hour. 50, so this is where I got the miles. Ooh, there's the miles. And here's the miles per hour. Sorry. Sometimes I see interesting animals out my window, and I wanted to see what that was. Let's see. Oh, so this is just a calculator thing, right? This is just a calculator problem right now. I'm going to turn my calculator back on. Help me out, Mr. Calculator. Tell me, oh tell me. There we go. Okay. And that's going to equal 24, and my short-term memory, 24.1551. Okay. So 15517. 241. 241. Okay. Am I done? Am I done? Huh? No, we're not done yet. So we know it's going to take Cantonio at least 24 miles. 24 miles. But I also got all of this right here, right? I got to figure out what all of this right here is. So, what I'm going to do is I'm going to subtract 24 from all of this right here, right? I'm going to take this number here, minus 24, which is going to equal, it's going to equal whatever this is here. Do you catch what I'm doing there? So I'm taking the big number, 24.155172241, subtracting 24, because I already know it's 24 hours. It's going to be some 24 hours of change, and I want to find out what the change is. So that's what the change is. That's what the difference is. And now I want to then convert this into minutes. How do I do that? Well, there is 60 minutes in an hour, so I want to take this, and I want to multiply it by 60. All right, so back to the calculator. Help me out, Mr. Calculator. If I subtract 24 from my big number, I get just the decimal. And please, Mr. Calculator, convert that into minutes for me. Great, great. So now it's converted into minutes, right? I times it by 60. I got equals 9 point, what was that? 31034. 31034. 9.31034. Going to keep me honest if I make any transcription errors. Hopefully I can start doing these YouTube live stream. You guys can actually participate with me as we're doing these. We'll see how that goes. Let's see. So where was I? Oh. Now the question asked to the nearest minute. I could stop right now. I could stop. But you know me, I'm Mr. Extra. I want to know what the seconds are. So I'm going to subtract 9 to just get the decimal. There's the decimal there. I'm going to multiply that by 60. Again, Mr. Extra. Okay, that's 18 seconds. That's 18 seconds, people. So here we go. 24 hours, 9 minutes. And I could have stopped there. I could have stopped there. But we're extra, right? And 18. Now we're going to round that up to 19 seconds. And 19 seconds. Alright. Or if you wanted to use 18.62 seconds, you would also be awesome. Okay? Now, if it was a Regents test and they were being persnickety, I'd probably just keep it right exactly, only answer what they want answered. But since we get to play around here, you know, heck, let's attend to some precision. Shall we? Alright. Feel good about these, I hope. These shouldn't be too hard. I wonder how I'm doing on time. Pardon me. Let me throw. Okay, we're at 31 minutes. Alright, thanks. Hey, just a little busy right at the moment. Alright, okay, what was I? Okay. Kate left Albany, New York, and traveled to Montreal, Quebec. Sorry about the bell. Distance from Albany to the Canadian border is approximately 176 miles. The distance from the Canadian border to Montreal, Quebec is approximately 65 kilometers. If the entire trip took her about 3.75 hours, 3 3/4 hours, what was her average speed for the trip? Okay? So here's how we're going to figure this out. It wants to know what the average speed was. So average speed, we're going to be finding the rate, won't we? So, Kate's average speed can be reported in miles per hour or kilometers per hour. To report her speed in miles per hour, convert the entire distance to miles. Change 65 kilometers to miles, multiply by a conversion factor of 0.621371. And so there's the 65 kilometers being multiplied by the conversion factor that will convert it to miles. We find that 65 kilometers is equal to 40.389115 miles. Pardon me. The distance from the Canadian border to Montreal is approximately 40.4 miles. Do you see that? They just rounded that up. Kate's total driving distance is the sum of the distances from Albany to the Canadian border and from the Canadian border to Montreal. So 176 plus 40.4. That's the number we got there. And I'm forgetting already where they came up with this 176 number. They already gave it to us in the beginning. So the distance from Albany to the Canadian border is approximately 176 miles. And so we add the 176 up with the 65 kilometers, which we converted to miles, goes in here. So we have a total of 216.4 miles. So there was some conversion in there. There was two pieces of math we had to do. We had to convert the one piece of our trip that was in kilometers to miles, then add that to the miles we were given in the beginning of the question, and now we're going to solve for rate, okay? So distance equals rate times time. We're going to divide by t on both sides, right? Divided by t on both sides gets rate by itself. This t cancels that t. Now we get distance divided by time equals the rate. We're going to stick in 216.4 miles that she traveled, and she traveled 3.75 hours. That's 3 3/4 hours. And then that will give us a rate of 57.7 miles per hour. We could round that to approximately, Kate traveled approximately 58 miles per hour. We could then, we could also use this to convert into kilometers per hour. Convert this all over to kilometers. Find that she actually drove 348.2 kilometers, and then do kilometers per hour and find that she was driving at 92.853 kilometers per hour, or approximately 93. All right. Does that feel good? These should be. I'm hoping this will be pretty easy for you to do. All right. So in the example above, could Kate's kilometers per hour have been calculated by multiplying her miles per hour by the conversion factor? So could we have just taken this answer here wait, where is it? Yeah, this answer here. Wait, this answer here, sorry. This 58 miles per hour. Could we have just taken the 58 miles per hour and converted it? Well, let's see. 58 miles per hour. Or we'll actually do 57.7. 57.7. And we know this is this is miles per hour. And we know that there is we can convert miles into kilometers, right? And we have a conversion for that. I don't know it off the top of my head. To convert kilometers to miles, multiply it by this. Maybe I have it over here, back in the notes. To convert miles to kilometers, there it is. Okay, so this is 57.7 miles per hour, right? And then we're going to multiply this by this conversion factor. Let's try it. 57.7 miles per hour times the conversion factor, which should convert this to kilometers. And let's see if our numbers are pretty close to what they got. 92.8589, 92.853. Okay, so these are pretty darn close. These are pretty darn close, but notice they aren't exact. Is this close enough for nearly every application in daily life? Yeah, it is. Is this close enough for NASA or an engineer? Probably not. So you gotta, interpret, analyze, understand what you gotta do. 92.859, 92.859. Did I get that anywhere near close? 8589. There we go. Kilometers per hour. Or H. Okay, example 4. Juan, let's see. All right. Juan has a hybrid car that averages 40 miles to the gallon. His car has a 12-gallon tank. How far can he drive on 1 full gallon of tank of gas? Maybe you've asked yourself this before. You filled up a car and you're wondering yourself, can I get to where I'm going, with just the amount of gas I've got here? Well, you can actually figure that out pretty easily if you know your fuel economy, right? If you know how much gas your car uses per mile on average. So the distance traveled can also be expressed as a function of the fuel economy measurement and the number of gallons used. So distance is miles per gallon times how many gallons you have, or kilometers per liter times how many liters you have. Therefore, the distance Juan can drive or travel on 1 tank of gas is a product of his miles per gallon and his tank size in gallons. So it told us here that he knows that his car goes 40 miles per gallon. He knows that his car has a 12-gallon tank. 40 times 12 is 480 miles. Juan can drive up to 480 miles on 1 tank of gas. Feel pretty good about that? All right, you try it here. Maybe you want to pause. Now would be a good time. Otherwise, here we go. I always encourage you to try to do these yourself independently. You learn a whole lot more when you're actually trying to do the work and puzzling it out on your own than you do if you just hear me explain it, right? It's like you can't learn how to shoot a basket with a basketball without actually putting a basketball in your hands and shooting it. You can't learn to play the piano by watching someone play the piano. You can't learn to play basketball by watching people play basketball. Sometimes you have to do in order to learn. And math is like that. You have to do in order to learn. So I encourage you, when I say pause, I do encourage you to do it, because sometimes you have to do to learn. Watching makes you feel like you're learning, but you're not actually building those skills. You're not actually activating those neural pathways in your mind that will help you bring it back and actually duplicate what I'm doing. All right, Renice. She drives a total of 500 miles on G gallons of gas. Express her fuel economy measurement in miles per gallon as an algebraic expression. So, she drove 500 miles on G gallons of gas. So her fuel economy is 500 miles per gallon, right? And of course, somehow Mr. Salt totally messed you up and said that this had to be a number. I will exempt you on this one, because I know I'm asking you to do it as an algebraic expression. I'll probably have this fixed by the time you actually do it. So don't worry about that. 50 miles per gallon. Am I done? 500 miles divided by however many gallons. That's her, I don't know, what do you want to call it? Fuel economy? That's her MPG, right? 500 miles divided by however many gallons she did is equal to her fuel economy. MPG, miles per gallon. As far as I'm concerned, you're good right there. That wasn't hard. That's done. I should have made that harder. Gave you some more stuff to put in there. Okay. All right. Example 5. Miles per gallon. Barbara uses her car for business. She must keep accurate records so that she'll be reimbursed for her car expenses. When she started her trip, the odometer read 23,787 miles, 0.8 miles. When she ended her trip, the odometer read 24,108.6 miles. Barbara's car gets 32 miles per the gallon. Her tank was full at the beginning of the trip. When she filled the tank, it cost her $40.10. What price did she pay per gallon of gas on this fill-up? Oh yeah, this is a nice problem. This is nice and twisted. There's going to be some steps on this. So first, we got to compute the distance that Barbara traveled, right? We got to find the distance by taking her last odometer reading, 24,108.6 miles, and subtracting her original odometer reading, which was 23,787.8 miles, and that gives us a difference of 320.8 miles. That's how many miles she traveled. All right, she traveled 320.8 miles. Her car gets 32 miles per the gallon, we're told. So we can use the D times M times G formula, distance formula, to figure this out. D is the amount traveled at 320, goes in there. Let's see, 32 miles per the gallon. That's going to be going for M. So we can say, okay, 300, she went 320.8 miles, which is going to equal the miles per gallon times how many gallons she drove. We're going to divide by 32 on both sides in order to get G by itself, right? 320.8 divided by 32 is going to give us 10.025 gallons. So we know she used 10.025 gallons of gas on this trip. If her total bill was $40, then we can use this number divided by the total amount of gallons to get the price per gallon paid. So if we know she paid $40.10, we know she used 10.025 gallons, we can find that she paid $4 per gallon for the fill-up. Okay? And again, I'm asking you to do this with algebraic expression, and I think it's another one of those number things. Darn it, I'll have to fix this, but let me try to give you an idea. They begin a trip with an odometer reading of A miles and end the trip with an odometer reading of B miles. So B minus A, that's going to give me the difference of when the odometer after the trip and the odometer before the trip. So this is going to be B minus A. This is the after the trip reading. This is the before trip meeting. We have to do B minus A to find the difference, which will give us how many miles she went. If the car gets C miles per gallon, we're going to then divide that, right? Because we found the distance by taking the differences. Found the difference to be 320. We then took 320, we divided by the miles per gallon. So now we're going to take this expression here. We're going to divide it by the miles per gallon. So divide it by C per gallon. And the fill-up cost for this trip was D dollars. And we took our 10 gallons of gas and we divided it by how much money. So then we need to divide this. Now, I might not have needed this extra thing here. I probably didn't need the extra parentheses. I probably could, but I'm going to do it just so you kind of see what I'm kind of thinking. That's it. Right? this expression here. Alternatively, if you wanted, you could have done some other different things. I can see there's a couple other ways of doing this, but this is one way of doing it. All right, I'm not sure. When I created these, I really liked these algebraic expression questions. I am taking less to a shine of it just because you guys really aren't into it. To me, this really helps you think, like, what am I doing? When am I doing it? How am I doing it? That's why I like these. Okay, last example. Example 6. I actually am going to do example 6 and I'm going to end this video because I think we're already good on time, and I want you to actually practice a lot of these, right? What are we at? We're at 45 minutes, so I've got 5 minutes or less to finish this up. David is driving in Mexico on his vacation. He notices that gas costs are 8.5 Mexican pesos per liter. All right. What is the equivalent? What is this equivalent to in U.S. dollars? Well, David first has to find his current currency exchange rate. The currency exchange rate is a number that expresses the price of one country's currency calculated in another country's currency. Remember what we did with the euros and the dollars a second ago? Up-to-date exchange rates are available on the internet. David needs to know what $1 US is worth in Mexican pesos. By the time of his travel, $1 US equals 13.3 Mexican pesos. So you divide the foreign currency amount by the amount he paid for gas and exchange. So he paid, sorry, that's going to ding like 7 times now. 8.5 Mexican pesos per liter. He knows that $1 US is 13 pesos. So 8.5 by 13.3 is 0.64. Each liter is going to cost him 64 cents. Now, we don't usually buy our gas in liters, do we? So we're going to need to convert that over. So you know that there are approximately 3.8 liters in a gallon. So David can multiply 0.64 by 3.8, determine the equivalent gas price if it was purchased with US dollars in person, purchased US dollars per gallon, and the price of 8.5 Mexican pesos per liter means he paid about $2.43 for a gallon of gas. So, there's a 7th example. Oh my gosh. Okay, well, on a trip through Canada, Daniel notices the average price of gas per liter was 1.28 Canadian dollars. If $1 US is equivalent to 1.0 Canadian dollars, what equivalent gas price in US currency? So first, my first thing is 1.28. This is Canadian dollars per liter, right? Canadian dollars. I don't even know how I want to do that. I don't know how I want to do CD in math. We usually like to do one letter. Canadian dollars per liter. I then need to convert this to US dollars. So what I'm going to do is say, well, there is the $1 US is equal to 1.0 Canadian dollars. So I have a situation where this is Canadian dollars per liter, and this is going to be equal to, let's see, no. So I'm going to divide this value here, 1.28 Canadian dollars per liter, divide it by the currency exchange rate, 1.07, to find out what this is in terms of dollars. 1.28 divided by 1.07. All right, so this is about $1.1920. Okay, 1.196. Okay, I'm going to take that out to two more decimal places. Just okay, and now what? Oh, I pushed the wrong button. Sorry about that. One moment. All right, so this is 1.19626 dollars per liter. I now need to take this and convert this over to dollars per gallon, right? So that's this, and then I have to times it by the let's see, the conversion rate, 3.8, right? 3.8. That's how many liters are in a gallon. So I go over here, there's my number, I'm multiplying it by 3.8 and 5.54. I'm sorry, I am bugging. 4.54. I misspoke completely. 579. All right. So I might we might end up rounding this up. What's the equivalent gas price per gallon? Well, it's about $4 and we'll say 55 cents per gallon. If you wanted to do the little what I've shown you in class, do the approximation symbol. We need a dollar sign now. Approximately $4.55, per gallon. Okay, I have an example 7. So David knows that the price of gas in his hometown is about $2.90 per gallon. How can he compare this price to the price he paid in example 6 for a liter? So David needs to express the U.S. gas price as a price in U.S. dollars per liter. There are approximately 3.8 liters in a gallon, so divide the price per gallon by 3.8 to divide the price per liter. So 2.9 per gallon divided by the conversion rate, there's 3.8 liters in a gallon, gives a 0.76. There are 0.76 U.S. dollars per liter. So gas is less expensive in Mexico because 64 cents per liter is less than 76 cents per liter. So to compare the prices in pesos, you'd have to then multiply the U.S. dollar amount by the exchange rate. The exchange rate was 13.3, so 0.76 times 13.3 is 10.11. So gas in his hometown would sell for about 10.11 Mexican pesos. Just as the comparison in U.S. dollars showed, the comparison in pesos shows that gas is less expensive in Mexico. All right, so if the average price for gas in Rochester is $2.81 per gallon, what is the equivalent price in Canadian dollars per liter? So you're going to have to go and find an exchange rate, which I think I gave you. I think I gave you an exchange rate in the beginning, I hope. If I didn't, you'll have to go online. But I was hoping I gave you an exchange rate. I didn't give you an exchange rate. I feel bad now. You can use the exchange rate that's already here if you want, or you can go search for yourself for an exchange rate, all right? And then the rest of these are questions that are all based off the examples we've already done, okay? So use those examples to finish the rest of these. I'm kind of thinking this will definitely be due by Friday, and we'll see how you guys do with it, all right? Have yourselves a good time off, and you'll be seeing more of these videos in the future, all right? Aren't you guys lucky? Have a good day now.